morning. Welcome to Tuesday. Today wraps up Chapter 9. We will be doing 9.5, mean absolute deviation. This is another way to do a measure of variation that we talked about yesterday. So the mean absolute deviation, otherwise can be shortened as MAD, is the average of how much data values differ from the mean. So yesterday we were focused on the median, the middle numbers of the different sets, okay? When we divided it into quartiles and we found the medians of each quartile. Today we're working on the mean, and the mean is the average, if you recall. So go ahead, write these steps down before you continue on further, because I want you to be able to focus as I'm talking about each step in finding this mean absolute deviation. So when you have a data set, the first thing you do is find the mean, and to find the mean, you know that we add up all the numbers in the data set and then divide that total by the number of numbers that were in the data set. Okay, that's how we find averages. Once you do that, you then find the distance between each data value and the mean. And I'll explain what that is when we do the first example here. Step 3 is you find the sum of step 2. Once you find the distance between those values, then you add all of those numbers up. And then in step 4, you divide that sum in step 3 by the total number of data values. Okay, so I'm going to do some highlighting in here so you can see where each step is. So the first thing we're going to do, let's write down the data set. Okay, and here we go with me being sloppy again. All right, A. So we have 1, 2, 2, 2, 4, 4, 4, and 5. Okay, so here's my data set. For mean, remember you don't really have to have those ordered from least to greatest because you're just finding the average. But they're already in order from least to greatest, so we're good to go. So we need to find the mean. All right, I'm going to highlight this as green. All right, so step 1 is going to be green. And we're going to find the mean. The mean is, we add up all these numbers, divide it by the number of numbers, and see what we get. So 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19. And 19 plus 5 is 24. So 24 divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 equals 3. So my mean is 3. Oh, that's covering it. I'm supposed to be highlighting. Jeez. Okay, if something would work, that would be great. Make sure I'm on the right thing. There we go. All right, so that was step 1. Step 2 is to find the distance between each data value and the mean. Okay, so what that means is if our mean is 3, then we need to find the difference between each data value and 3. So for example, I'm going to look at number 1 here. All right, number 1. The difference between 3 and 1 is 2. The difference between 3 and 2 is 1. The difference between 3 and 2 is 1. 3 and 2 is 1. The difference between 3 and 4 is 1. And then the difference between 3 and 4 is 1. 3 and 4 is 1. And 3 and 5 is 2. Alright, so basically we're just taking that mean and each data value and determining what the difference is between those two numbers. So I'm going to highlight this one red. Okay, I found the difference. I took 3 minus 1 and got 2. 3 minus 2 and got 1. 3 minus 2 and got 1. 3 minus 2 and got 1. The difference between 4 and 3 is 1. 4, and so forth. Okay, so now step 3 states that I need to find the sum of step 2. So I'm adding these. Okay, so now I need to add all these together. Okay. And when I add these together, I get 2 plus 1 is 3, 4, 5, 6, 7, 8, plus 2 is 10. Alright, so I found the sum. And I'm going to highlight this one blue. Alright, so that was the sum of step 2. And then step 4 is divide that sum in step 3 by the total number of data values. Okay, so 10 divided by, there were 8 data values. Okay, and so 8 goes into 10 one time. I get 2. Let's add a decimal, bring it down. 8 goes into 22 times. I'm left with 4. Let's bring it down another decimal. 8 goes into 45 times. All right. So hold on, let me highlight that this is step 4. So my mean absolute deviation, or MAD, is 1.25. And this means that the data values differ from the mean by an average of 1.25. And I'm going to go ahead and add that here so you can write that down. The data values differ from the mean by an average of 1.25. Okay, so there's that. Let's do one more. Alright, so here's my data set. I have 0, 0, 0, 2, 4, 4, 5, 6, 6, and 8. Better 8. Oh, goodness. 8. Okay, first step, find the mean. We got to add up all these numbers, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and divide it by 10. So when I add up all these numbers, I get 35 divided by 10, which will give me a mean of 3.5. Okay, so now that I have 3.5, now I need to find the difference between 3.5 and each of those data values. Okay, so should have moved this down a little bit. Let me rewrite this here so I have some space. 35 divided by 10 equals 3.5. Okay, so the difference between 3.5 and 0 is 3.5. And then this is 3.5. this is 3.5. The difference between 3.5 and 2 is 1.5. The difference between 3.5 and 4 is 0.5. And then I have another 4, so it's another 0.5. The difference between 3.5 and 5 is 1.5. And then my 6, 2.5, 2.5, and then my 8. Difference between 3.5 and 8 is 4.5. Okay, now I need to add all of those together. If you have your calculator, you just add 3.5 plus 3.5 plus 3.5 plus 1.5. Add them all up. You get a total of 24. 24 divided by 10 equals 2.4, which is my mean absolute deviation. Okay, let me know if you have any questions on this. You're going to practice with a short assignment tonight, and then you're going to practice this lesson some more on IXL, and then you will be ready for your quiz. All right, thank you so much.